Okay, here we go. Thank you for joining in this session. My name is Paul, and I'm working in a company which is BrainCube, and we are doing industrial IoT. Industrial IoT is really about optimizing production line, and it's basically about big data, EA, and digital twin. So basically, it's nothing in relation with what we are doing here. So that's my daily activity. My nightly activity is a bit different, so I'm this91, and I'm basically a device maker, solution provider. I'm an open source writer, blogger, YouTuber, teacher, many things. And I'm also a network provider. I'm working on Helium community. Do you know Helium here? Who knows Helium? Yeah, some knows, lots knows Helium. That's good. And the question of the talk today is how we can innovate in the LoRaWAN ecosystem without modifying the specification. So innovation is also about architecture, and I'm going to talk about architecture. I'm sorry for the one in your room that are really expert on LoRaWAN, because I will maybe pass through open doors with some basics, but it's interesting to understand where we are going. So what is the most typical architecture we see on LoRaWAN? It's private networks. And what are private networks? It's different stage, like we're going to find every time. Starting from the device, the message goes to a gateway, a set of gateways. And one important point is that compared to 3GPP, the message is received by all the gateways around. That's going to be important later. Then, this gateway is pushing the message. It's pushing every messages to the LNS. One other thing which is important. The message is not filtered by the gateway, which means, as we are in a radio protocol, every message from your device fleet, but also from the device fleet of another guy on another company, is also proceeded by your gateway. So your gateway transmit all this frame to the LoRa network server. I will use LNS for the next. It's going to be more simple. And the LNS role is to receive this packet, filter this packet, validate that packet, and push them to an application. And that's the objective of what we are doing in IoT. We are gathering data, bring them to an application, and extract value from this application, this set of data. We try to create something better, higher, a new knowledge based on this. It's a different topic, but we can go on this. So that's private implementation. And on private implementation, it means that you own everything. The same guy is owning the device fleet. The same guy is owning the gateway. The same guy is owning the LNS and running the application. Sometimes the LNS is subcontracted, but you own your own instance. That's a great model. But the problem is you have to be good on devices, could be good on application, could be good on gateways, and also on software for the LNS. It also means that you have to support the running cost of everything. And the cost of running gateways, running LNS, is really important in your TCO. So we have a second model that is really classical, which is a public model. In the public model, you say, OK, the most part of my TCO is in the gateway owning and the LNS management. So instead of paying 100% of this on myself, we're going to share this. And so we have public operators that appears and basically manage gateways from different fleet of devices and manage LNS. So the service provider owns the device, owns the application, and runs public operator services. I've made a study, it was, I think, 5 years ago, about when it started to be interesting to have a private architecture. And basically, we can challenge this number. But my result was, if you have less than 2,000 devices, it don't really make sense to manage your own gateway and own LNS. It's not the investment cost. It's really the running cost, which is really high. So it's better to go to mutualization in that case. You can do that for different reasons, like privacy and security. But in terms of TCO, this model is interesting. OK, nothing new on this. The problem of this model is that the cost, the running cost of the gateway, renting the rooftop, managing the gateway is really expensive. And as a consequence, having global public and operator on LoRaWAN, where the volume of device is not so high yet, is a challenge. We've seen that in French. We had 2 public global operators. Now we have 1. And it made a mess on the market. So we can optimize this. And here we go to another architecture, which is quite interesting. It's a crowdsourced architecture. And this is not new. The crowdsourced architecture has been invented at the same time as LoRaWAN has been specified. In fact, there are some crazy guy somewhere at the event at the Thing Network that say, hey, instead of having one company managing the cost of the gateway and so on, we're going to ask people to do that. We're going to ask the service provider to do that. Because as I explained, all the gateway are processing all the message from everyone. So instead of going to the LNS and trash the message that you're not owning, yeah, it's better to process this message. And we can share the coverage. We can share the cost. That's the idea of the crowdsourced architecture. And it has been really interesting. I mean, it works. And in this architecture, I'm the one that's going to deploy the hotspots, the gateways. Or you're the one that's going to do it. But understand that when we are saying citizen, it can mean Paul Pinot, I mean, as a citizen, as someone that just wants to share its connectivity or just want to play with something. But it can also be Paul Pinot as BrainCube or Paul Pinot as Ingenious Things that is doing it for business activity. So crowdsource does not mean bad quality. Crowdsource means sharing. OK? Because if I deploy it for my business, I will make sure that the SLA is good. And this is what we see on the market. So in this architecture, we have the gateways costs that are shared across citizens, and it makes really not expensive. I don't have to rent my rooftop. I don't pay myself to reboot the gateway or to upgrade the gateway if it's needed. OK, it's some hidden cost. That's good. And we need a public part, which is the LoRa network server. The interest of this is to say we're going to connect all the gateways to a public LoRa network server. And basically, this architecture is the one that is been deployed by the Thing Network in 2015. So there is multiple advantage on such architecture. As we say previously, we mutualize coverage. We mutualize the investment in gateways. We can also get benefit of existing coverage. It creates redundancy, or it creates coverage for somewhere you want to deploy a device fleet. It basically, at the end, reduces drastically the network total cost of ownership. And in parallel, you get the advantages of having a managed LNS. You don't have to care with that, with the update, with the high availability requirement, and so on. This architecture, as I say, is not new. The Thing Network or the Thing industry, that's the same thing, company versus community, has reached over 30,000 gateways deployed in this spirit. And now they are managing 1 million devices, and it's growing really fast. So the trust on the market on such pattern, such architecture exists. It's there. Now let's talk to another one, Helium. Helium is fresh new in this area. It's something that did not exist 2 years ago. And this network is up to 900,000 hotspots deployed worldwide. That's far away the biggest LoRaWAN network in the world. It currently runs about 100,000 devices, I don't have the exact number, rough estimate. It's not a lot, but you need to understand that this number, 900,000, has been achieved in something like a year. It's really faster to deploy the network than to create the trust and make the device arriving. But it's growing very fast. So we're close to 1 million of hotspots deployed. The reality is that we have something like 480,000 active hotspots on the network. It's something like 10 times covering the whole Earth in terms of LoRaWAN. The reality is that we have a big concentration, so it's not the real coverage, but it's just to give you ideas on what does mean this number of hotspots. The network is processing currently about 1 billion messages a year. It's a lot. And one of the power of this is if you had device on this network, it will cost you, for using the network, under $1 a year. But when I say that, it can cost you 10 cents a year. Because when I talk about innovation, it's about technical stuff, but it's also about business model. And what is totally different on a such network is that you can have pay per message transmission. So it means that if you have a device that sends one message, you pay only for one message. That's clearly interesting in terms of business case, particularly when you want to do B2C devices, where model with recurring subscription is really a problem to deploy. What does this number mean? It's currently, as I say, it's the biggest global network in the world. It's 70,000 cities deployed, and it's 190 countries where the network is. It's global. One particular thing of this network is that it's an ultra-dense LoRaWAN network. That's interesting. Since 10 years, a bit less, 8 years, we are talking about LoRaWAN scalability issues. We have researchers trying to resolve this problem and so on. What is LoRaWAN scalability issues when your cell is under 300 meters? There's no problem of scalability in such things. It's also create values. What about locating devices, assets with their SSI? When you have an ultra-dense network, you can get a precision of 100 meters. That's quite interesting. So there's plenty of application on this. So let's take Orlando to have an idea of what does that mean, ultra-dense. In Orlando, you have 1,600 hotspots, and you have, right now, 900 hotspots active, 900. I was in a bar yesterday with a tester, and we had 5 hotspots responding. We are in the middle of nowhere, and we have 5. So, how do we get this success? This success comes from crypto. And, you can like or dislike crypto. I did not come to Helium or to IoT because of crypto. But what I see in this world is that crypto in IoT is a real accelerator. And we had a discussion yesterday about crypto is all about Ponzi stuff and so on. Here not. And this is what I like in such project. It's about providing a service and making money entering into the system from the service, not for getting the system running, just to provide a service. And here the service is a communication service. So it's a standard business model, telecom company. You give money for connectivity. And the principle is mint and burn equilibrium, which basically means when I want to buy a communication service, I'm going to pay for this service in dollar, in fiat. And for this, I will destroy with this. I will buy token and destroy token. So I will reduce the quantity of token. And on the other end, for providing this service, the gateway owner will get token. So it's burn and mint equilibrium. I destroy token, I create an equivalent token for making the service. Okay? Crypto is something that's frightening everyone. I mean, I'm quite sure that if you go to see your boss and say, hey, we're going to use a crypto network, you won't do that because you're really afraid to be fired or something like this. It can be innovative sometimes, but it could be frightening. But you need to understand that, I say, it's a service like any other service. In fact, if you want to use the network, you're on the yellow part. It means that you're just using your credit card or classical invoicing system, and you get communication. So there's no crypto for using this network. The crypto comes at the LoRa network server owner. So basically the one who is providing the connectivity, like I do with my service, like anyone can do on the network. And so the role of this LNS owner is to buy the crypto part, transform it into data credit by burning it, and then the blockchain will distribute their data credit into HNT to the hotspot that transfers the packets. So basically, how does it work? You have a device, which is a standard LoRaWAN device. It has nothing specific, okay? This device is sending a message through the gateway, and the gateway sells this message to the system. The system buys the message, and if the message is bought, it's pushed to the application server. So it's like a classical system with a transaction between two. But it's not just like this. There is something that is really innovative. A big differentiator, in my point of view, is that Helium is a multi-LNS network. It means that in the architecture we've seen previously, we can have different LNS. We can have public LNS. We can have private LNS. It means that any one of you can create its private LNS on Helium, or can create an LNS that becomes public and offering connectivity to the other. That's really interesting. It means that if you create your private LNS, you basically have your data that will be end-to-end encrypted, even if you have an access to the whole number of hotspots that are deployed. So basically, the million hotspots that are connected is like it's yours. And that's quite interesting. You have public services, like Helium is providing public services. My service is helium-iot.eu, so I'm a part of this. And you can create yours. There is currently something like, I think, 40, 45, or 50 different LNS that has been deployed. And I think we have something like 20 that are active. Okay? How does it work? Basically, a device sends a frame. This frame is going to the gateway, or hotspot. We call it a hotspot in a Helium ecosystem. And the difference is that this hotspot is running a small process. And this process is identifying what LNS is targeted by this frame. And it's routing the frame to the right LoRa network server. So say, OK, the problem is that we need dedicated hardware. And yeah, it's not wrong. There is dedicated hardware to do that. There is also standard hardware with just a piece of software you had on it. But you can also use your existing gateway fleets and just move this piece of software in a server somewhere in the cloud. It works also. And that way you can easily migrate your existing fleets and getting benefits of the redundancy of the thousands of different hotspots you have around yours. That would be interesting. That was the previous architecture, which is currently evolving. This architecture was really good because this architecture is you have really a direct connection from a hotspot to an LNS. It's totally decentralized. But this architecture had some problem in scalability mostly. And so to make the network more reliable, more scalable, the architecture is evolving. And in the evolution of this architecture, we are now having, and it's a first step, a central routing system that is currently re-centralize the network, but it's a step before going back in decentralization. And this routing solution will do the same as the software we described previously, which basically means we also simplify the hotspot software to manage the communication. By doing this, we create reliability and we eliminate the risk related to the scalability inside the hotspot. The other thing that is evolving is the use of any LNS. In the previous architecture, what I didn't say is that the LNS was a Helium LNS, which was a great product, but it was not supporting all the class of devices and so on. So now the system is supporting any LNS, and it starts with Chirpstack, but it could be Activity, it could be the Sync Network LNS. It's totally agnostic. And by doing this, it opens new possibilities. So in this architecture, what needs to be done is something to make the link between Chirpstack and between the routing infrastructure to declare the device, to manage the payment, and these kind of things. And it's the only thing that has been that has to be developed is to make the link between the two. And it's basically a project I'm working on. So that's why I'm talking about this detail. It's an open source project, so you can check my GitHub with my name. You will find it. And if you want to do that, you can manage this. So basically, we got hotspot which is simplified, more reliable, more scalable. We have a reliable solution for routing. We have an agnostic LNS solution that could be Chirpstack to start the system. And basically, here we have something new. We have something that is growing. We have the first LoRaWAN network in the world, and we have more and more devices in it. I finished my presentation about this architecture. I will be happy to get some questions from you, and we can stay in touch. So you have my Twitter handle. You can follow my blog, where there are a lot of technical blog posts about all of this, and you can connect on LinkedIn for sure. I really like to be in touch with tech guys or IoT passionate people. So if you have questions, the floor is yours.
Just a quick question about fine timestamps. Are those being implemented, or have they been implemented already, planning to be implemented? No?
Sorry, excuse me.
Fine timestamps of the packets, of the payloads on the gateways. Can we see fine timestamps?
Fine timestamp. No, currently I don't think there is an implementation of this. But maybe you can confirm if yes or not. But I think it's right now. You have NTP on the gateway usually, so you have this timestamp. So, but it's not. You think about TDOA or thing like this? Yeah, we had discussion about this. So I think it will arrive. But right now, there is not this thing. But what is interesting is when you are in a city, TDOA performance is really bad, like a 300 meter or thing like this. When you are in an ultra-dense network like Helium, in a city, I think that with a bit of EA or just mathematics, we can get something that could be better than TDOA. Outside city, I mean, TDOA will be really far better. But inside city, I think we have something really interesting.
Previous slide, can you clarify the distinction between NovaLab's role in that architecture in Helium?
Yeah. So, as I said, here, if we take this architecture, basically, NovaLab did not add a role in it. It's fully decentralized, okay? If we take this new architecture, which, as I said, is more a first step to a future architecture, NovaLab is managing the routing part. Let me know if it's NovaLab or Helium Foundation. It's Helium Foundation that is managing it. Yeah. So but there is a big difference. I mean, a short difference between NovaLab, which is a company that produces the software, and Helium Foundation that is making the network running. So this part is basically managed by Helium Foundation, the routing part. For all the rest, it's widely open.
So to go back to the crypto you were talking about previously.
Is this one?
Where that building's happening, the entities in that, the next slide.
In that side?
The next one up, the one we're
Yeah.
looking at.
Yeah.
The one that has an overlap depicted in it.
Here,
That's the slide.
here there's no overlap. In this one?
Correct.
Yeah.
I guess I'm confused. The business entities NovaLab versus Helium Foundation and the blockchain, that diagram. Can you clarify that?
So, Helium Foundation and NovaLab has basically don't have business on this. The business of NovaLab and Helium is for every block that is calculated, there is HNT that are generated, and a part of their HNT goes to Foundation and goes to NovaLab. That's the business of NovaLab and Foundation, basically. So here, there's no specific business for them. They manage through the HNT generation, they manage the cost of the routing infrastructure, okay? But there's no business for them here. They don't take money, they don't take DCs. All the DCs that are spent by the device owner goes to the LoRa network server owner. That's clarified, or? I don't know, I can clarify.
I don't want to drag this sideways too far with that, but it's not clear to me. I understand, it's not clear to me who's making the business there, NovaLabs or Helium Foundation.
None of them. None of them, in fact.
Owns all the intellectual property. All the security keys are controlled by the foundation.
Here, business is at the LNS. We are in that business. It's a communication provider. Sorry. So, okay.
It's not zero cost for NovaLabs to perform that routing function, right? So how does that happen?
Well,
This isn't appropriate to talk about.
Yeah.
NovaLabs is a startup, and they have their own funding. So they have funding, startup funding, so they can do things like that. They can manage infrastructure to bootstrap.
Another say, every block on a blockchain, a part of the generated tokens goes to NovaLab founders and to Helium Foundation. This is basically, it has value. So this makes this architecture running, okay? But for sure, the target we must have is that this routing architecture goes out of NovaLab or Helium Foundation control, because we want this to be decentralized. And so, at this point, they will not be part of this, which is basically a blockchain should not rely on any company. That's what we need to achieve. Bitcoin do not rely on any company. So this is really what we need to do. So this is why there's no fees get in the middle of the communication of things like this. Here, the business model is really directly between the device owner and the LoRa network provider. Clear? We're going to talk later if you want to have, for sure. Yeah, go ahead.
Sorry for the question. I come from the legacy technical.
Yeah. So, for example, I'm here. I'm Helium IoT Europe, okay? I'm a company. You buy a service to me, and you pay this service at a higher cost than I have to retribute the guy who has the hotspot. So the difference between the money I give to the hotspot owner and the money you give me for this service is to provide you a certain level of service.
Okay, I understand that. Previously, you mentioned that there's a total number of gateways that roughly half of them are active.
Yeah.
So how does Helium, whether you or any other company, guarantee that there's minimum coverage within a specific area with active gateways?
There's no guarantee of this. Yeah, there's no guarantee. I mean, it's citizen deployment. So how we are trusting the network? We are trusting the network for different reasons. The first one is the redundancy. I take the example of my city. In my city, there was a public operator, and it has 10 gateways around. With Helium, we have 200 gateways for the same city. So we can have 10% of people that are going down, having an internet problem or anything like this. We still have 180 hotspots that are available. And if we think about reliability, on the 200 gateways, we have all the internet providers available on the market. So if there is a problem with the backhaul on one internet provider, we have the one that will be broken. So that's one of the things. The other thing, when you are a service provider and you want, for example, to go to smart cities, maybe you cannot say, okay, I'm going to sell a service for 10 years relying on Helium. I can't do that, but I can take a risk by doing this. In my point of view, the right way to do that is say, if I do it out of Helium, I will have to deploy 10 gateways to cover the city and to create the reliability. But now, if I go with Helium, I will myself add 3 hotspots that get a coverage, and I manage it, so I manage the SLA on this, and I will get the access to the 200 other one that creates the reliability. So basically, by adding professional service into this ecosystem, we are also creating the reliability because we are the ones that care about this. So this model is, I mean, it's quite interesting. It's really about optimization of TCO at the end. If you have any other question, otherwise I think I need to leave the floor. Tell me. Okay, so if you want to continue the discussion, I will be close to the door here. Thank you for your attention.